Hello guys, welcome back to the channel. My name is Oscar. Recently, I just graduated with a diploma in machine learning, and I'm making this tutorial to share my knowledge with you. So today we shall be looking at machine learning, where we shall be basically unlocking the potential of machine learning. And your presenter for today is Opio Oscar. So first of all, let's begin by understanding what machine learning is. Machine learning is a field of study that enables computers to learn from data without being explicitly programmed. It basically focuses on pattern recognition and prediction. That's a brief overview of what machine learning is. Now, let's look at and also let's compare the traditional programming versus machine learning. So traditionally, we used to have that's input and a set of rules or a set of program logic, and after which we have an output. But with the introduction to machine learning, programming paradigm has changed a bit, whereby we have input, output, and then a model. In this case, these are learned rules, and these rules are learned with the help of data and algorithms. So we can see that with the introduction to machine learning, the programming has changed. So let's go ahead and look at the types of machine learning. So there are basically two types of machine learning, that is supervised learning and unsupervised learning. So when you talk about supervised learning, we basically look at labeled data being fed into the algorithm. Then when we look at unsupervised learning, we look at unlabeled data being fed into the algorithm. But we shall look at all this one by one in our next slides. So let us begin with the supervised learning, what actually it is. So with supervised learning, we basically look at, or we use what you call labeled data. And what do you mean by labeled data? It means that we have an output and a correct we have an input and a correct output. So our algorithm learns to map the input with the corresponding output. So what are the examples, or what are the applications where we see supervised learning being put into use? One of them we have that is predicting house prices. We have spam email detection. We have that is disease diagnosis. That's where we see supervised learning being used a lot, plus other applications. Then we have unsupervised learning. In this case, it uses unlabeled data, finds hidden patterns, groups or structure data. For instance, we see this being used a lot in areas like customers segmentation and then pattern discovery. So with that understanding of the types of supervised learning, let us go ahead. Now let's look at what is a model. So once we get a better understanding of what a model is, then that will make everything flow smoothly. So a model is simply a real world phenomenon. In this case, we can equally say it is a mathematical description of relationship in data. Now we also see that we have basically two types of models. We have what we call deterministic model, and then we have what we call probabilistic model. So what do you mean by deterministic model? So in this case, with deterministic model, there's no randomness. Then with probabilistic model, there we're dealing with randomness and uncertainties. That's basically what a model is. Then let's proceed to understand each of these types of models. So let's begin with deterministic models. So in this case, just like we talked about, there's no randomness, then there's exact relationship. Then another thing we can also talk about is prediction error is negligible or almost near zero. For instance, where do we see this in real life? For examples, so one we have in physics formulas, in mathematical equations. So in this case, you know, if to predict a given value, if the model has been defined and you insert the input, what you get is very deterministic. There's no uncertainty involved. Now let's look at what we call probabilistic models. So in this case, this is probabilistic models include deterministic component and the random error component. So when do we use? In this case, we use in real world data which contains uncertainty or uncertainties. So what are the types of probabilistic models? We have what we call regression models, we have correlation models, and other probabilistic models. The list goes on. Now let's look at what we're calling regression models. So a regression model shows relationship between dependent and independent variables. It's basically used for prediction. Now let's also take a look at the steps in regression modeling. One, we have to first hypothesize deterministic component. Then secondly, when you're done with that, we go ahead to specify probability distribution of the error. Then third step, we go ahead to evaluate the model. Then once everything is okay, we go ahead to use the model for prediction and estimation. So that's it. That's a brief description about what regression models are. Then we have what we call linear regression. In this case, it models relationship as a straight line where we have that's the formula y equals mx plus c. In this case, mx plus b rather, where m is the gradient, b is the constant. And where do we use this? We use it basically for predicting continuous values. We see this a lot in, let's say, sales prediction, then predicting house prices. That's where we see linear regression being used a lot, plus other usages. And when to use it depends on the problem you're trying to solve. Then let's proceed and look at what we're calling least squares. So in this case, once we're using our linear regression, we need to get what we call line of best fit or best fit line. So in this case, what you try to do is that we want to minimize the difference between the actual and the predicted values. So this reduces total squared error, and in this case we say that best fit equals smallest prediction error. So that is with least squares. Now let's talk about logistic regression. What is it actually and what is it used for? So this is an algorithm that is used basically for classification and predicts probability, and output is between 0 and 1. It's basically used for one, spam or no spam. We have looked at email classification. We want to get to know whether an email it is a spam email or it is not spam. It's used in fraud detection, let's say in banks. Sometimes, let us say, transactions are very small amounts or extremely high amounts. So the logistic regression algorithm helps us a lot. Then you also use it in disease detection. In this, for example, that is, let's say, in cancer detection. So that is with logistic regression. Then let's look at what we call KNN, that is k-nearest neighbors, and what actually it is. So this is instance-based learning and it classifies based on closest data points. In this case, there's no explicit training phase. So let's look at how it works. Okay, the first step, what you do, you choose the k. K in this case, the neighbors you are considering for a given test data or for a given data point. You can say k can be 2, 3, 4, 5, depends on your choice. Then what do? You find the nearest neighbors. So after finding the distance between the nearest neighbors, what do you do? The last step is you go with basically the majority vote for your classification of a given data point. Now let's look at what we call decision trees. Just like the name suggests, it is tree-like structure, uses questions to split data, and one thing with it is actually very easy to interpret. So what are some of the advantages? Just like we said, it is simple, it is visual, and handles categorical data. So that's a brief summary or overview of what decision trees are. Now let's look at what we call ensemble learning. So what's ensemble learning? In this case, what we do, we combine multiple models and train them either sequentially or in parallel. And with the ensemble learning, why we use ensemble learning, you want to improve on accuracy and you want to reduce errors. And the main key idea here is to ensure that whenever we're having weak learners, many weak learners, we combine all of them and we have one strong learner. This with the ensemble learning approaches that are basically used, we have boosting and we have bagging. That's something that we can dive on deeply later on, but just to introduce you or to get you started with your machine learning, that is something that you'll definitely have to cover and understand thoroughly. So having got what ensemble learning is, let's talk about random forests. So in this case, random forest, what is a forest first of all in intuitional or in just normal understanding? A forest is a collection of trees, but in this case, in computer science or in software engineering, we look at these trees. It is an algorithm basically. So in this case, a random forest consists of multiple decision trees. So what happens is that it uses random subsets of data, and what we normally try to do is we are trying to reduce overfitting. And why does it actually work? In this case, what we are trying to achieve is averaging, which reduces variance. That's a brief info about random forests. That's something that you'll definitely have to cover and understand thoroughly. Now let's proceed and look at support vector machines, that is SVM, what it is. So with this, our goal, or when you use this algorithm, your main focus is to find the optimal boundary between classes or spaces, and between the classes you're trying to get the boundary. What you do, you draw that line, what you call the margin, and the distance between the line of separation and the other class. That's what you're calling the margin. And what do you want to do? You want to always maximize that margin, and this can be handled using using nonlinear data, and what we basically use is what you call Kernel tricks, or what you call kernels. Kernels can be linear, can be quadratic, can be polynomial as well. And what do you use support vector machines for? We basically use support vector machines for classification. We use it for pattern recognition, and other more usages. So that's basically about support vector machines. Now let's look at what we're calling principal component analysis, that is PCA, what it is and why we need to use it. So it is basically used for dimensionality reduction. What is a dimension reduction technique? Let's say when you have a data set, and you're having very many sets of features, we can decide to engineer the features so that we structure the features in a way that it gives us the most information out of the data without losing the most important information as well. So what it does is converts many features into fewer components. And one thing to keep in mind, it is always it keeps most important informations. Now you may have in mind, why do we need to use that is PCA, that's principal component analysis? One of the reasons is it speeds up training of the model. Then two, it reduces noise in our model. Then three, it prevents overfitting. Then let's proceed. And we have come to the end. Just like I told you earlier on, here I basically wanted to share with you what I've learned. You can equally explore more other resources, and I hope that helps. See you in another episode or tutorial. Thank you and bye bye.